Hey guys, my name is Dan Nakure. I'm from BS Honors BSci program, online degree program of IIT Guwahati. I'm presenting my project, a term project for Trimester 7. My term project's name is Hybrid Manga Recommendation System using content-based and collaborative filtering. The problem statement of my project was that there is a huge growth in entertainment industry, especially Japanese content entertainment industry. There is manga means Japanese comic books. These comic books are later adapted into anime shows. Uh, there is a huge population chunk of people who loves to read these mangas. But as this industry is increasing a lot by size each year, uh, people only get to gets recommended the popular mangas and struggle to find their own personal preferences or mangas which suits their taste. Uh, I wanted to build a system which will recommend personalized manga options to these people and let them explore their own personal the mangas which fit into their own personal choices. So we built for the dataset for this project was fetched from Chicken API. It provides us the manga dataset of MangaDex app. We applied some filters to this fetching process, like there was applied a minimum score and how many minimum people should have rated that manga because of some constraints for in the later development phases, like deployment phases. The fetching the this feature fetches manga using pagination. Then the fields which we are fetching are title English, like ID, by which ID they are storing it in their system, so that it later becomes easier for us to show this information to users in later phases. The type of manga, like what type of manga it is, synopsis, genres, like what genres it represents, themes, some demographics, and there is authors, score, how many people scored it, rank, popularity, and etc. stuff, which uh, this API provides by itself. We also paste image URLs for later show this information to users themselves during recommendations. Then this page, after removing some duplicates here and there, we stored this data set as a CSV file. Then we pre-processed it during the recommendation phase. During this phase, we combined some attributes and built a content attribute. This content attributes combines genres two times. Why it does that two times is to increase the weight of characters in genres. Like synopsis has a very is a very huge content, like very huge text size, so it can overshadow genres. That's why we used genres two times, appended it two times, and themes, demographics, and synopsis. After this appending, we formed a TF IDF matrix, which forms a matrix based on how much weightage a weight should have in this passage. Like if there is some weightage, this like word like the are not very common and do not impact too much, so there should not be given any weight to them. But some words like action, adventures, these words should carry some meaning, and that's why these words are given more weightage. These are some high value weightages, as you can see. Um, then we also finally process that data set and then saved it as a CSV file. During the build manga, we also developed, like in later phases, we also developed the cosine similarity matrix, which like TF-ID of vector gives weightage to these words, right? The cosine similarity matrix like sees how much these vectors for each manga are similar to each other. zero, it scores them from 0 to 1, like 0 meaning there is no similarity, and 1 meaning they are exactly the same. This similarity matrix was also calculated. For guest users, we are using the collab collaborative content-based filtering recommendations, as we don't have their own ratings, and we need their ratings to give them some sort of recommendations using content-based filtering. Now, this to do this, mm, we basically get a single manga title from user, like he likes Naruto, or he has watched some Jujutsu Kaisen, like some manga he has recently read, and we want to find mangas which are similar to it. So we find the similar mangas in cosine similarity matrix. Then these similar mangas, some are sampled based on their scores, and only the top scoring mangas are then presented to user at the front end. We also used a hybrid recommendation for like this hybrid recommendation. We used content-based collaborative filtering. We combined it. We used SVD matrix method for collaborative filtering. To combine these two recommendations, what we did was, first we get a top 50 content-based filterings, content-based filtering mangas, like the mangas which are similar to this manga. These the given manga by user, the top 50 mangas. These top 50 mangas were then later filtered using collaborative filtering. We only showed top 8 mangas to user after this. But to do that, we also did that. The problem which we faced was CBF gives similarity score from 0 to 1, right? Cosine similarity matrix. And collaborative filtering as SVD method gave us similarities score from 1 to 10, right? So to tackle this, we actually did some normalization here. You can see, and after the final score is generated, based on this final score, we recommended a limited number of mangas to user. That's how work is for code is working behind the scenes. Let's see. This is our base onboarding page, which user sees when he sees opens the application. In this onboarding page is designed to tackle the cold start problem. Here, user will give some sort of ratings to randomly selected mangas. Uh, like this like type of some popular manga, right? Then during once these ratings are finished, we get into the main page of the recommendation system. Here, user will see some random mangas, which we will also ask, which will show on randoms. After this, we ask a user for some name of the manga which he wants recommendation for. Once we get the name of the manga, we ask him to click on this, and then we see that his recommendation is completely done based on CBF, like content-based filtering. So these are the mangas who have the synopsis and genres and everything is similar to the manga which user gave us, like Naruto. So Naruto Gaiden, Boruto, these are like sequels and prequels of that manga. Um, Based on this is like CBF system. So if user is already signed up with in the system, so then uh, as user is already signed in, like these preferences will ask more for his ratings. Like we have already have some ratings about of users, but we will need some more then ratings. User will type the name of manga which he needs some recommendations for. Then recommendations will be showed based on a hybrid model, which will use CBF as well as uh, collaborative filtering for recommendations. This is like the live demo of the app. For evaluation, first, these are the top 10 cosine similarities, average of top 10 similarities. Average was 0.175. For collaborative filtering, we generated synthetic data as we did not have a lot of user data. Using this synthetic data, we found RMSE and EMAE. Then hybrid precision for this hybrid model, we use precision at 10. Uh, then we did this for 50 users. And this was also synthetically generated. Uh, this we got 0.0020. And to conclude, in conclusion, I developed this recommendation system. From what I learned from this whole project was more, I learned more about recommendation systems, how to use CBF, collaborative filtering strategies. I also learned more about data scraping, database building, data exploration, uh, and also about web development, like how do you develop backend systems like Flask. I used Flask for this. We deployed this application using a render, and that. Thank you.